which is suitable for manufacturing. After cutting the boards, they come to the drilling room. Drilling is done for two purposes: for connecting the leaded components and for the via holes that link the copper layers together. First, the operator takes a MDF board as exit material. Then he loads one or more PCB panels and places it on the machine. And finally adds a sheet of aluminium as entry foil. Those machines are computer controlled. After selecting the right drill program, the machine starts working. Drill change is fully automatic. The machine selects the drill to use from the drill rack and checks that it is the correct size, and then loads it into the drill head. This is a air-driven drill which can rotate up to 150,000 revolutions per minute. The high-speed drill makes the whole walls cleaner. After that, the corners are trimmed to make it rounded. Then, the surface is cleaned. The machine automatically smooths the edges of the boards, one side at a time. As the board has drilled for making connection between top and bottom layer, but the middle layer is non-conductive fiberglass. So to make connection between top and bottom layer, the board comes for electroplating. The operator loads the panels onto the flight bars. The panels themselves act as cathodes for electroplating. The panels are carried through a series of chemical and rinsing baths by the overhead crane. This is a multi-stage process and everything is controlled by computer to ensure about 1 micron thick copper has deposited over the walls of the hole. After that, the board goes through a series of process where copper is plated up to a thickness depending on the required final finish for the panel. This process took about 40 minutes of time, and then board automatically goes to the another room for next step. Then panel is first coated with a layer of photosensitive film, the photoresist, which is hot rolled onto the copper. This machine do this automatically or sometimes done this process manually. This film is blue light sensitive, so all the lights into the room is yellow, so the light does not affect this film. Then the operator cleans the films. The film is the one which already has printed circuit diagrams on it, and loaded the first film. Then put the laminated panel and finally the second film. After perfectly aligning both layers, the board is sent to the printer. The printer uses powerful UV lamps to harden photosensitive film according to the circuit printed film. So after this process, only the circuit part is hardened and rest unwanted areas remain soft. Modern machine can do this whole process automatically. Next, the board is processed through a chemical solution or developer that removes the unhardened and unwanted resist from areas that were not polymerized by light. After this, you can clearly see only the circuit is printed by blue resist, and this material will resist the chemical at the etching process. Then the board is sent for the etching. This process is to remove the unwanted copper using a powerful alkaline solution. After etching, the boards need to be cleaned and washed to remove the excess chemical solution. Then the boards come for automatic optical inspection or AOI. This machine enables fast and accurate inspection of PCBs to ensure that the quality of product leaving the production line is high and the items are built correctly and without manufacturing faults. When detecting circuits, the machine automatically scans the PCB through the camera, collects images, and compares the tested solder joints with the qualified parameters in the database. When everything is okay, then the board comes again to another yellow room for solder mask. This coating machine simultaneously covers both sides of the panel with epoxy solder masking. Solder mask is required to protect the copper surface and prevent solder shorting between components during assembly. After applying solder mask, panels are now racked and put through a conveyorized dryer at 87 degrees Celsius, which hardens the resist just enough for the next stage. Usually it takes almost 25 minutes to bake. Solder mask is applied to all over the board, so to remove the solder mask from solder pad, first the operator takes the PCB and then align the photo film carefully at both sides simultaneously. The UV lamp in the machine hardens the ink while the film is clear. Later on, the unhardened and unwanted resists are stripped off. Most PCBs have a component legend to show which component goes where. They use inkjet printers to image the legends direct from the board digital data. This printer is very advanced. The operator only needs to find the silk screen file corresponding to the board and set the positioning on the main control computer. Then the ink will be applied on the boards evenly and automatically. Moreover, it can also be printing and curing on the same system. To protect the copper of solder pad from oxidation, hot air solder leveling is often chosen as surface finish method for circuit boards. In addition to the usual HASL, they also provide a variety of surface treatment methods such as immersion gold, hard gold and OSP for customers to choose according to their needs. Finally, the PCB production process is done. Then they electrically test every multi-layer PCB against the original board data. Using flying probe tester, they test the high voltage insulation and low resistance conduction of the circuit boards and check each net to ensure that the circuit is complete and there is no short or open circuit. For high volume production, they use automatic e-test machine which saves time and money because it runs at a high rate. After all testing, the boards come into the milling room. Now it's time to separate all individual PCBs from the large production panel. The operator loads one or more PCBs onto the CNC machine. And choose the right program for those boards. according to customer needs. The board or array can also be V-scored so that they can easily be broken apart after assembly. After milling, the board comes for cleaning. This machine cleans dust and oil stains using ultrasonic waves. After wet cleaning, the boards are dried. Then a team of sharp-eyed inspectors give each PCB a final and careful checkover. She looks for any cosmetic defects like scratches and marking, also checks aperture, thickness, holes, etc. After inspection, the PCBs are vacuum sealed and bubble wrapped to keep out dirt and moisture.